Hello everyone, my name is Vanessa and in this video I will be discussing about properties and natures of light. So first of all, we must understand what light is. Light is a form of energy which is radiated from a source and is detected by the eye in a form of radiant energy. Light that we can see is a member of electromagnetic spectrum or EM waves, which is called visible light. Light is also a heat carrier, which means that light is a form of energy that can be converted to heat to operate chemical or physical processes. Another reminder is that EM waves do not require medium for propagation. Example is that sunlight can reach Earth without any medium, and that is because it is an EM wave. EM wave consists of two waves, which is electric and magnetic. The range of frequencies of electromagnetic radiation and their respective wavelengths and photon energies are divided into 7 in the electromagnetic spectrum. As you can see, the gamma ray has the shortest wavelength, and the longest wavelength is the radio wave. The shorter the wavelength, then the bigger the frequency, because frequency is inversely proportional to the wavelength. The higher the frequency, the higher the amplitude. Gamma ray has the highest energy, while the one with the lowest energy is the radio wave. This is a picture of a wave. This straight line here is called an equilibrium position. This part here is called the node, which is the intersection of the curve on the equilibrium position. Any point of the curve that doesn't intersect with the equilibrium position is called an antinode, while the highest point of the wave is called the crest. The lowest point of a wave is called the trough. The height of a wave is called amplitude. There is a positive amplitude and there is a negative amplitude. The distance from one crest to another crest is called a wavelength. One wave cycle is equals to one positive wave and one positive wave. Next is natures of light. First one is light as a particle by Sir Isaac Newton. It introduces the corpuscular theory of light, stating light consists of tiny particles or corpuscles which travel along a straight path. This describes two things about light. First is light reflects. Reflection means the bouncing of light. For example, it's like how a ball would bounce off a surface. Second is refraction, which is the bending of light. As you can see from the example here, the picture on the left shows that light can refract through a medium with different densities because of the sudden change of speed in light, which causes the chopstick to look bent. The bigger the density, the slower the speed of light, and if the density is smaller, then the speed of light is faster. Since in this picture, light travels from air which has smaller density to water with bigger density, it looks as if the chopstick has been bent downwards. The picture on the right shows reflection. In this picture, the source of light is the torch. It produces light, and when it hits the mirror, the light somehow bounces to the wall. This can only happen if the light hits off a reflective surface, such as a mirror. The second nature of light by Christian Huygens, which stated in his theory of light, light is a range of frequencies of electromagnetic waves whose wavelengths vary from 400 nanometer to 700 nanometer. This means that visible light in the prism can be divided into 7 colors with different wavelengths as shown in the light spectrum. The 7 colors are red, which has the longest wavelength of 700 nanometer, orange, yellow, green, blue, indigo, and violet, which has the shortest wavelength of 400 nanometer. This is called dispersion. It refers to the spectrum of the white light into different colors of spectrum due to its refraction as light passes from one medium to another. Now I'll be talking about color addition and color subtraction. First is color addition. The primary colors of light are red, green, and blue. The secondary colors of light are cyan, magenta, and yellow. Take a look at this video. As you can see in this video that I'm showing you now, the secondary colors are colors that are formed from the addition of two primary colors. Blue and green can overlap and form the color cyan. Red and blue can overlap and form the color magenta. While red and green overlap will form the color yellowish green, but more yellow. So when the three of the primary colors are mixed, it will form a complementary white. It will form the white, because white light is the mixture of all pieces of light. So if we mix all the colors of light in this light spectrum, it will form white. If you're wondering why the primary colors of light are red, green, and blue, well, it's because there aren't actually primary color. Any color in the spectrum can be called as primary colors. But because the human vision uses the trichromatic system, which means that we are only sensitive to 3 colors of the light spectrum. Red, green, and blue is used to serve color is because the 3 types of cones in our eyes responds highest to waves with frequencies approximately 565 nanometer, 535 nanometer, and 420 nanometer, which shows that our brain can interpolate how far and which direction towards red or blue. Where the light source is strongest, our brain can interpret secondary colors like cyan because they are actually made out of 2 different wavelengths. There are many colors humans perceive that cannot be created by a single wavelength of light. Next is the subtraction of light. It refers to the removal of some frequencies of light as light passes a color filter to produce a new resulting color. Pigments are used to work on principle of color subtraction. Pigments are chemicals that absorb certain wavelengths, therefore preventing certain wavelengths of light from being transmitted or reflected. The 3 primary pigments are cyan, magenta, and yellow, while the 3 secondary pigments are red, green, and blue. Cyan, magenta, and yellow are the primary pigments because they only absorb one frequency of color. While red, green, and blue are secondary pigments because they can absorb 2 frequencies of colors. The color cyan absorbs red and reflects green and blue. The color yellow absorbs blue and reflects red and green, while magenta absorbs green and reflects red and blue. When mixing pigments, you can only see the color that both pigments can reflect as shown in this diagram. When you mix 3 of the primary pigments, it will absorb all the secondary all the secondary pigments, therefore creating an absence of light which will appear black. This is the reason why things that are colored black are more exposed to heat than white, because black absorbs all of the incident rays and reflects none, while white reflects all the frequencies of light. Still on the topic of subtraction of light, what happens when light attempts to go through different color filters? Let's look at these diagrams below. Notice that on the blue filter, only the blue, indigo, and green was able to pass through the filter. This is because the blue filter absorbs the color whose wavelengths do not fall on the range of blue light. Even though indigo and green was able to pass through the blue filter, we won't be able to see it because it's not the dominating color. The most dominating color that will pass through the blue filter will be blue. Therefore, our eyes can only see the color blue. Same thing applies on the green filter and the red filter, based on their color. For the rest of the color that is being blocked by the filter, it creates a shadow instead, because of the absence of light on this part. Next, we will be calculating the frequency, wavelength, and energy carried by light. These are the formulas for the calculations. V is equals to lambda times F. V here is the velocity and lambda is the wavelength, while F is frequency. This applies when calculating the speed of light, which is equal to 3 times 10 raised to 8 meter per second. So speed of light is equals to the product of wavelength and frequency of wave. To calculate the energy carried by light, we'll have to use Planck's constant, which is equal to 6.63 times 10 raised to negative 34 joules second. So energy is equal to the product of the Planck's constant and multiplied by the frequency of the wave. Here are some example questions. So for the first question, it is given that lambda is equals to 700 nanometer, which is equal to 7 times 10 raised to negative 7 meter. And we are asked to determine its frequency and energy. Based on the formula C equals to lambda times F, we can now transpose F so that we can find frequency. Now we'll just insert the numbers and we will now get 4 times 10 raised to 14 Hz as the frequency. To find the energy, we use the formula E equals to H times F. Since we already found its frequency, we'll just have to insert the numbers. And now we will get 2.65 times 10 raised to negative 19 joule. For the next question, it's given that energy is equals to 3.315 times 10 raised to negative 19 joule, and we are asked to find its wavelength. Since frequency is not given, we'll have to substitute the F from the other formula. So since F is equals to C multiplied by lambda, F is equals to C divided by lambda, we'll have to substitute the F, and now we can write that E is equals to H times F, then we'll get E equals to H multiplied by C divided by lambda. Then we can transpose the formula and To find lambda, that will be equals to hc divided by energy. And now we insert the numbers. Now we will get 6 times 10 raised to negative 7 meter or 600 meter as the wavelength. Moving on to the characteristics of light. We've discussed about reflection and refraction already. Now let's talk about diffraction and interference. Diffraction refers to the ability of waves to pass through the slits or barriers by bending the waves. While interference happens when there are two or more waves that overlap with each other. As you can see in this picture here, the straight line here symbolizes the wave's cross. And when it passes through a slit, the wave will bend around the slit. The only thing that will change here is the direction of the waves traveling. The smaller the gap, then it will be more bent to follow the size of the slit. Interference, on the other hand, is caused when two or more diffractions from the respective slits overlap. This will cause an interference pattern, which is shown here. You can see alternatives of bright and dark spots. The bright spots are caused by the overlapping two waves in phase that you see in this vivid red line here. When we say two waves are in phase, it means that their frequencies are clearly aligned, perfectly aligned, and have a phase difference of 0. When this happens, the amplitude of the waves will be summed up and produces a wave with an amplitude as big as the sum of the two waves. The screen appears bright because waves carries energy. This is called constructive interference. While the fade red line here is caused by the overlapping of two waves with different frequencies. Therefore, their amplitude will cancel each other out and results in a wave with a smaller or 0 amplitude. When that happens, the energy carried will be lower or none. That is why the screen appeared dark. This is called destructive interference. Next is reflection of light. There are two types, which is the regular reflection and diffuse reflection. Regular reflection has light rays that are parallel to each other and can only happen when light bounces in a smooth surface. While in diffuse reflection, the light rays are in a random direction and it happens because light bounces in a rough surface. The law of reflection. First statement said that the incident ray, the reflected ray, and the normal lies on the same plane. Second statement states that the angle of incidence is equal to the angle of reflection. The line here in the middle is called a normal line and is always perpendicular to the surface. The incident ray is the ray that is produced by the source of light, while the point of the surface where the incident ray hits is called the angle of incidence. Now let's do an example question. In this question for letter A, it asks us to show the path. So since it said that the angle of incidence strike mirror AB at 20 degrees from the mirror, it will look like this. And then, of course, the reflected light will bounce again in mirror BC, causing it to reflect again. So it should look like this. Now for letter B, to find the angle of incidence at AB, we'll just have to subtract 20 degrees from 90 degrees since the normal line is here will be 90 degree to the surface. So 90 minus 20, and we will now get 70 degree as the answer. Now for letter C, it wants us to find the angle of refraction in BC. I will be putting letters here so that it will be easier to explain. So since the incident ray of AB is equal to the reflected ray of AB, we can now find the angle of BDE by subtracting 90 degree by 70 degree, which gives us 20 degrees. Then we can now find angle BEB. Since the total sum of the angle in a triangle is equals to 180 degree, it will be 180 minus 120 minus 20, which will give us 40 degrees. After that, we can find the angle of incidence at BC by subtracting 90 degrees by 40 degrees and get 50. Since the angle of incidence and reflection in a plane are equal, then the angle of reflection at BC is also 50 degrees. That is all for this video. Thanks for watching.